Okay. All right, here we go. Which of the following are exponential functions? If they are, state if their growth or decay, state the rate of growth and decay, and state the initial value. All right, let's go through and answer for A through F. Let's go through and decide if they're exponential or not. Now, you might not know this already. I'm going to tell you that A is exponential. So look at A. That type of equation is exponential. I'm going to tell you B is also exponential. But I'm going to tell you C is not. So what do you think it takes to be an exponential equation? If A and B are, but C is not, what is kind of the key thing? X is the exponent. Your variable is the exponent. And exponential is some number times some number to the x. That's an exponential. So, are you automatically exponential if you have an exponent? No. What makes you exponential is your exponent is the x. Okay? So what do you think about D? Yes. What do you think about E?
Yeah.
Now be careful. That's a tricky one. It actually isn't, because the exponent is okay, but these guys, the A times B, those are numbers. Those are numbers. So this is like 3 times 2 to the x. You can't have another x in there. So an exponential has one x, and it's the exponent. Okay, is that clear? That one's a little tricky. E's a little bit tricky. All right, what about F? Yes. Okay. So, are we good on the first part of the conversation? Can you tell if an equation is exponential or not? Okay, then let's move on. If they're exponential, state if they are growth or decay. So we're done with C and we're done with E. We're not gonna have any more conversation, they're not exponential. Now, I'm gonna tell you that A is a growth and B is a decay. And I'll give you a hint. It has to do with the number that has the exponent. That number is called the base. And it has to do with the base. Notice that in problem A, the base is 1.23. In other words, it's bigger than 1. What happens when you multiply something by a number bigger than 1? It grows. It gets bigger. If your base is bigger than 1, you're going to get bigger because you keep multiplying by 1.23. Now what happens in B is we're multiplying by 0.83. Well, what happens when you take 0.8 of something? It goes down. So that's decay. So how do you tell if you're growth or decay? You look at this number right here, the one with the x. If it's bigger than 1, you're going to grow. If it's less than 1, you're going to decay. All right? So what do you think about D? Growth. And what do you think about F? Decay. All right, are we all set on that conversation? We can tell if we are growing or decaying. All right, next. State the rate of growth or decay. Now that is going to be a percentage. So like 12% growth, okay? Or 12% decay. Remember that the number, let me just write one down here. This first one. Remember that the number that determines if your growth or decay is this one. And the key is it bigger than 1 or less than 1, right? That's the key.
What if it's like just one?
Well, remember, if you multiply by 1, what happens? You don't change. So it's not part of the conversation. The base will never be 1. Okay? Now, the amount that this number is bigger than 1 or less than 1 is your rate of growth or decay. So this number right here is 0.23 bigger than 1. So that means this is 23% growth. The amount that your base is different from 1. So it's 0.23 bigger than 1, it could be 0.23 less than 1. The amount that it's different from 1 is your rate of growth or decay. So look at the next one, which is this. Now here's the number you're looking at. How much is that less than 1? 17%. So this is 17% decay. Okay, you guys? All right, now I need everybody to listen, because this is one of those bugaboos that catches us. I know this problem has a 0.83 in it, but you will never say 83%. That never, ever, ever is what you'll say. To get your percentage, growth or decay, is how much more than 1 or less than 1 you are. So that's 17 less than 1, so it's 17% decay. But at the end of the semester, so it's like December 20th or something like that. Right? Okay. All right. All right, D was a yes. Okay? How much more than 1 are we? 2%. So this is 2% growth. And how about F? 8% decay. Now, does everybody understand where that 8% came from? 1 minus 0.92, that's exactly right. And if you can't do that in your head, you can do it on your calculator. 1 minus 0.92 comes out to be 0.08, so 8%. Okay. All right, and then the last question, this was like a 4-part question. So the last question is state the initial value. When you talk about something growing or decaying, doesn't it have to start somewhere? I mean, you have to have a starting value, right, that you either grow from or decay from. The starting value, the initial value, is this guy right here. That is your initial value. So A, the number A, the one that doesn't have the X, is going to be your initial value. So for problem A, our initial value is 3. For problem B, it is 1/2. For problem B, it is 100. And for problem F, it is 3.6. Easy. Okay, so that, number 1, all those examples are like vocabulary issues. Can you tell if something's exponential? Can you tell if it's getting bigger or smaller? Can you tell how much bigger or smaller it's getting? And can you tell where it started? We don't answer any questions about it. It's not exponential. All right, let's move on to the second part. I gotta fix my attendance here. So everybody finally made it before I said.
Oh, it's 100 right there. So I'll use the thing.
Alright, number
Oh, I'll
2.
put the, okay.
Now we're going to write the equations of some exponentials. Okay. So that means our goal is y equals a times b to the x. That is what an exponential looks like. So when it says write the equation, that's what we're gonna do. That's what we're shooting for. Now, I know there are 2 points sitting in front of you, and we have kind of programmed you. When you see 2 points, you're gonna try to find slope. No, 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 no. Slope is for what? Lines. This is not a line, this is an exponential. And you'll remember from your BFFs, exponentials look like that, right? Not a line, so no slope. Instead, start with the number with the 0. One of your points, I promise you, one of your points will be 0, comma. Okay, start with that one. This is your x, this is your y. Plug it in. So 2 equals a times b to the 0. So take your first point, the one with the 0, put y in for y and x in for x, and it looks like this. Now before you get all freaked out, remember, anything to the 0 power is 1. This is 1. So basically, doesn't that say 2 is a? So now I know that number is 2. So y equals 2 b to the x. I put 2 in here because I just figured out a was 2. Now what do you think I'm going to do? Take the other point. So 6 equals 2b to the first. Remember, this is x. So it's going in for the exponent. So what is b to the first? 3. We divide both sides by 2. So what's my equation? Y equals 2 times 3 to the x. Your job is to write that equation right there. So we plug this point in first, found A. Now we're plugging this point in, and we found B. When you write your answer, it's just like that. Don't multiply the 2 and the 3. Don't make it a 6. These are 2 separate numbers. A times B to the x. Never combine, ever. So A times B to the x. Okay, let's try the next one. Remember what we are shooting for, what our goal is. Is y equals ab to the x, right? That's what we're going for? Okay, where do we start? Who remembers? Plug in this guy right here. Now remember, this is x and y, so that's what you're plugging in for. So 1/2 equals a times b to the 0. Now what does that tell me? What's b to the 0? 1. This is not, b to the 0 is 1, guys. Anything to the 0 power is 1. So this says 1/2 equals A. And then, remember, I'm trying to write that equation. So now I can say y equals 1/2 b to the x. Because I know A is 1/2. Now what do? Plug in the other point. So 8 equals 1/2 b to the second. How do I solve that? Could I multiply both sides by 2? So 16 equals b squared. And then square root. So b equals 4. And what is my answer then? My equation? Y equals 1/2 times 4 to the x. And never combine those, ever. They stay separate. Always, always, always. All right, you ready to give one a try on your own? This is what you're shooting for, and here are your points. So see what kind of progress you can make. If you need a calculator to help with the arithmetic, well, I don't care, go ahead. I hope everyone is plugging in the 0 point first. That's always the one we start with. Did you get A to be 6? So then you put 6 in for A, and you put this in for X and Y, and then you got this. It's a little tougher equation to solve. I need to move this 6 over here, right? I can do that a couple different ways. One way would be to divide by it. Another way would be to multiply by 1 over 6. Will that take care of it if I multiply by 1 over 6? And then that is a little easier for me in terms of the arithmetic. Multiplying by 1 over 6. That actually reduces. Do you know what 3 over 48 reduces to? Not 1/4. 1/16. And you remember over here when you square rooted, you didn't have any issues with that, square rooted, you were gonna 4th root. Anybody know what the 4th root of 1 is? I'm doing each part individually. The 4th root of 1 is, yeah, guys, any root of 1 is 1. And then what's the 4th root of 16? No. 4 times 4 is 16. I need 4 of something. 2, 2, 2, 2. So B is 1/2. What this means is something times itself 4 times is 16. 2, 2, 2, 2 is 16. So your answer, 6 times 1/2 to the x. Because A was 6 and B was 1/2. And I absolutely get that there's some arithmetic involved there. You guys are capable of doing have the patience to do it. You can do it. All right. Have you noticed anything, by the way? We've done 3 examples now. Has anything kind of struck you as you've been going through and finding A and B? What has A been every time? Well, it came from the Y of the point that had the 0. Did you notice that? That when we started with 0, 6, A was 6. And when we started with 0, whatever, it was always A was whatever. So you can actually, if you want, skip this step because that will always be the case. In your point with a 0, this number will always be your A. Now, if you don't want to remember that, or that doesn't make sense to you, then you'll work it out. But when I look at problem D, and I know this is my goal, I know automatically A is going to be 10. The initial value is the y-intercept. And the y-intercept is 0, comma. Remember, plug in 0 for x. Okay, so now I got some really awful arithmetic. 80 over 27 equals 10 times b cubed. Now, would you all agree we got to get that 10 to the other side? We can do that 2 different ways. One way is we can divide by 10. What is the other way? I just did it here. What's the other way? Multiply by 110. So b cubed equals, now look, 10 goes into 80 8 times. So this just equals 8 over 27. And now what do I do? Cube root. So b equals, okay, here we go. What's the cube root of 8? One piece at a time. Cube root of 8 is 2. Because 2 times 2 times 2 is 8. 3 of them. What's the cube root of 27? 3. Because 3 times 3 times 3 is 27. 3 times 3 times 3 is 27. So the cube root of 27 is 3. Cube root means what times itself 3 times gives you that number. Okay? Now, you guys, arithmetic is hard enough for you. I'm not going to give you craziness. This is perfect. This is beautiful. This is the kind of numbers I'm going to give you. Okay? Cube root of 8 is 2. Cube root of 27 is 3. Okay. B is 2/3. And my answer is 10 times 2/3 to the x. That is your equation. Okay? Ms. Ford, am I supposed to know what the cube root of 27 is? Yes! You're a senior in high school. Cube root of 27 is 3. I'm not going to ask you for the cube root of some wacky huge deal. I promise. The AP kids on their test yesterday had to find the 56th root of something. We're not going to do that. We're going to do cube roots and square roots and simple roots. All right. Okay. Part 3. Now we're going to simplify exponents. This is what we kind of practiced yesterday, but not completely. We kind of reviewed yesterday. Now we got some new stuff going on. So we have 8 to the 1/3, 16 to the 1/4. We are not going to type these in on our calculators. Certainly you could. Your calculator will do this. But we are going to do these by hand. Again, they're not going to be wild and crazy. They're going to be just the basic problems. So let me tell you, or maybe you already know, Do you remember from before? Anything about how to do like 8 to the 1/3? Anybody know what that means? I'll tell you, it's real easy. When your exponent is a fraction, it automatically means you have a radical. So every single one of these problems is going to be a radical because they all have an exponent that is a fraction. Okay, so what's the first thing? If we don't know this, we're gonna make a note of it. If the exponent's a fraction, you have a radical. Some kind of root. Whatever the base is, that's what's under the radical. So this is gonna have an 8 under it. This is gonna have a 16 under it. This is gonna have an 8, a 16, an 8, a 16, a 9, and a 25. Okay, you good on that? Gonna be a radical, and the base number is what goes under the radical. Now, the exponent, there's two parts to it. The denominator of the exponent tells you which root you're taking. So this is a cube root. The numerator tells you what power you're gonna raise it to. So this is a cube root to the first power. Okay, what's the cube root of 8? We just talked about it. The cube root of 8 is 2. And 2 to the first is just 2. So the answer is 8, or the answer is 2. 8 to the 1/3 is 2. All right, now what about this one? This one says the 4th root to the first power. Now what is a 4th root of 16? Now what that means is what times itself 4 times would add up, or would multiply out to be 16? 2. So this is 2 to the first, which is just 2. So 4th root of 16, 16 to the 1/4 is 2. All right, now this one's a little trickier. Remember, the denominator tells you the root, and the numerator tells you the power. So what is the cube root of 8? Well, we just did that. The cube root of 8 is 2, but this time we have to square it, so the answer to the problem is 4. See how that works? And they're all gonna be like this. All right, what's happening here? Well, it's gonna be a 4th root cube. So 4th root of 16, we already talked about it. Do you remember what the 4th root of 16 is? 2. But this time we have to cube it, so our final answer will be 8. 2 times 2 times 2. 2 cubed. All right, try this one on your own. Can you do this one? It means the cube root to the 4th power. Can you figure out what that is? What's the cube root of 8? 2. What's 2 to the 4th? 16. 2 times 2 times 2 times 2. Right? All right, here we go. Tell me what this means. Square root cube. Remember, denominator is root. That's the root. I had a kid tell me once she remembered that because where are the roots of a tree? Under it. Where is that too? Under it. So this is the root. Square root of 16 is 4. And 4 cubed means 4 times 4 times 4.
Yep.
64?
Yep.
What's this one?
3.
Well, it means the square root of 9 cubed. What's the square root of 9? 3. And 3 squared, or excuse me, 3 cubed is 27. Last one. Anybody got this one figured out? This is the square root of 25 to the first, so the answer to that one is 5. Fractional exponents mean radicals. A fractional exponent is a radical. The next section of problems is negative exponents, which we have sort of already talked about earlier in the year. What do you remember about negative exponents? Oh lordy, we talked about yesterday. What happens when your exponent's negative? Goes to the bottom, moves, right? So this right now, that number right there is 4 over 1.
1 over 6.
That number is 4 over 1. I am raising it to a negative power, so it's going to become 1 over 4. To the positive exponent. When you flip your fraction, the power then becomes positive. So what's 1 to the second? 1. And 4 to the second is 16. So that answer is 1/16. Okay, now, remember, the original number is 5 over 1. So what is that negative going to do? Make it 1 over 5, and then it's going to make the exponent positive. So 1 over 5 to the first is just going to be 1 over 5. Now this one, be careful. First of all, are you going to multiply these two together?
No.
Absolutely not. These are both over 1. Are they both going to flip? Absolutely not. Only that one's going to flip, right? That's the only one with the exponent. So this one's going to stay 2 over 1. What's this one going to become? 1 over 3 squared.
So 2 over 9.
So I'm going to have my 2 over 1, but what's this going to become? 1 over 9. So the answer to the problem is going to be 2 over 9. Okay, there's places to screw up here all over. Be careful. Take it one step at a time. The 2 has nothing to do with the exponent, so it isn't flipping. It's staying 2 over 1 the whole time. This guy is flipping and squaring, so he becomes 2 9. Okay, how about here? What's going to happen to this guy? He's going to become 4 over 1 squared. And what's 4 squared? 16. You can write 16 over 1, but no one does. It's just 16. What's going to happen here? 3 over 2. Still cubed though, don't forget that part.
27.
So 27 over 8. Whoa, how'd we do that? 3 cubed over 2 cubed. Here's another one, two-parter. Is anything happening to this? No. So he's staying 1/2. This originally is 5/1. So he's gonna become 1/5. So the answer to the problem is? 1/10. Yep, very good, very good. Try the last two, see if you make any progress with the last two. I got 5/2 and 1/81. Anybody have a question about either one of those? Anything about those two that you're unsure about? Okay, so one more time. A fractional exponent means you have a radical. A negative exponent means you flip your fraction. So now we're gonna do both. Okay, so we have 8 to the negative 2/3.
Red.
So, step 1, flip it. Do the negative first. The negative is the first thing you do. So this is 8/1, so it's gonna become 1/8. The exponent doesn't flip, not the exponent. This number flips. So 1/8 to the 2/3, you with me? Now, that's a radical, so I'm gonna have a radical. Under the radical is gonna go 1/8. This number goes under the radical. The root I'm taking is 3, and the power I'm raising it to is 2. So do each piece. What's the cube root of 1? 1. What's the cube root of 8? 2. And now you still gotta square it. So the answer will be 1/4. Now there's a lot of steps there. Did you follow all of those? You're gonna do them in that order. So you're gonna deal with the negative first. So in this next problem, remember, it's 4/1 originally, so it's gonna become 1/4. Now look at that, make sure that's okay with you. What flips? This number right here only. What does the fact that that's a fraction mean to me? Radical. So under the radical is gonna be 1/4. The root is gonna be square root, and the power is going to be cubed. So here we go. What's the square root of 1? 1. What's the square root of 4? Square root of 4. 2. Square root, right? Square root of 4. Not 4 squared, square root. And then I'm going to cube it. So what's 1 cubed? 1. 1 to anything is 1. 1's just 1. And then 2 cubed is 8. So the answer to the problem is 1/8. a lot of you work ahead. Anybody got C done yet? Anybody have C done yet? Nope. All right, one step at a time. What's the first thing I do? Flip it. So it's gonna become 9 to the 1/2. Now again, you can make that 9 over 1 if you want to, but it's not necessary, it's just extra. When I flip 1/9, I get 9. This means a radical. Under the radical is 9. It's a square root to the first power. What's the square root of 9? 3, and since it's the first power, it just stays 3. Step 1. Flip. So 27 over 8. I know there's, just flip it. Leave them alone, just flip it. 27 over 8. Now that is a radical. The radical will be a cube root of 27/8 to the first. What's the cube root of 27? 3. And what's the cube root of 8? 2. And since this is the first power, I don't need to do anything. It's just 3 over 2. All right, try E.
Take that back.
Talk it over with your partner if you need to. Let's see what kind of progress you can make with E.
Oh, I already did that. Tell me. Oh, 1 over 9. Flip it so it's 1 over 27.
Yell it out.
Huh?
So yell it out.
Oh, my bad. And then you got,
Willow, I think I heard you say 1 over 9,
yeah.
and you are right.
Yeah, yell it out.
Anybody have a question about where 1 over 9 came from? Again, lots of steps. Take it one step at a time, and they're really not that hard. Okay, how about the next one? What are you thinking? 1 over 16 to the 3/4. Remember, what flips? The only thing that ever flips is this number right here, right? Not the exponent. Never flip your exponent. So this is a radical, and it will be a 4th root cubed. 4th root of 1. 1. 4th root of 16. 2. But now I have to cube it, so I'm not done yet. What's 1 cubed? 1. And 2 cubed is 8. 1/8 is the answer. All right, we got 4 more to do. Work on these 4. Right now, let's regroup in a couple minutes and check our answers. Let's see if you can get these last 4. Let's see, that was there.
You get 2. You stick out. good.
Alright, anybody need me to walk through how I got 2 for number G, G? G was 2, did you get that one? 2, alright, for, H, I got 1 over 27, anybody need me to walk through that one for you? Okay, did you make it to I?
Yeah.
I flipped it, I got 1/10. And then J, I haven't done yet. You help me out. What did you get here? 100 over 9 to the 3 halves.
That's
Did you get 1,000
Over
over
27?
27?
Yes.
Wow, that's awesome. Okay, we're gonna stop there, and you are going to do your 3-1 homework, and it will be due on Monday. Now, another thing that I gave you the other day, you got 3 things from me. You got notes, you got homework, and
I
then you
got
got this extra little worksheet thing. I'm not assigning that, but if you wanna do that,
Intro coming up.
practice, you
What's that
can.
thing about that?
Answers are there, so you can do some extra exponent practice if you wish, not mandatory. But at some point, we're gonna be having.
I thought he was joking. When he emailed her mom,
You need to be.
he said, here you go.
I think I got time to catch
Oh, you need a towel now?
Well, on this stuff. Getting your homework.
Oh, yeah. I don't need no. 1,000 over 27.
But, you got it.